Hi, everybody. I'm going to go over with you the reteaching for 4-3, which is the commutative property, or I like to call it flip flop or flop around. Anyway, let's read the top where it always gives us on the reteaching side kind of the gist of what this is going to be about. An array shows objects in equal rows. This array shows 3 rows, 1, 2, 3, of 6 pennies. 1, 2, 3, 4, 5, 6. So the multiplication sentence for this array is 3 times 6 equals 18. You can use the commutative property or order property of multiplication to multiply the numbers in any order. So here we go with the flip-flop. So 3 times 6 equals 18, but you can flip-flop around these numbers and do 6 times 3 equals 18, and they both are the same product. So let's go down at the bottom, and it says to write a multiplication sentence for each array. And you can do the commutative property down here if you'd like to, if that, actually, since we're talking about it, probably wouldn't be a bad idea. So if I'm looking at rows, I have 1 row and 2 rows. So there's the first number, so 2. And then 1, 2, 3, 4, 5, 6, 7, 8. My second number. And if I count, I could do 8 plus 8, or 2 times 8 is 16. Now, if I'm doing the commutative property, I can flip-flop around these two numbers and put the 8 first and then the 2. Is it going to change my product? Nope, it's not. It's still going to be 16. Okay, let's look at this problem. So we have 1, 2, 3, 4 rows. And we have 1, 2, 3, 4 squares in each of those 4 rows. And if I count them out, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is my answer. Now, in this case, we can't flip-flop them because they're the same. But let's go down to the next one. Complete each multiplication sentence. You can use counters or draw a picture to help you. Really, I'm not so sure. You're welcome to use counters or you're welcome to draw a picture if you want to, but I think just with your eyes you'll be able to see the combinations here because there's a lot of flip-flopping going on. So we have 3 times 4 equals 12. I see a fact family, the 3, the 4, and the 12. If I'm looking over on the opposite side, okay, I have my 12 that matches up. Draw my little picture. And then I have the 3 that matches up. It looks like the only number that I'm missing in my equation to the right is the 4. All I did was I flip-flopped the two numbers around from 3 times 4 to 4 times 3. So you're welcome to use the counters or draw a picture, but sometimes it's just easy to look at the actual problem and see what you're missing. So let's look at the other side. So we have 5 times 2 equals 10. 2 times bleh equals 10. So I have my 10s as the product. 5, do I have a 5 on this side? No, I don't. So it's probably going to go into the blank. So 5 times 2 is 10. 2 times 5 is 10. Yep, that's what was missing. Okay, let's look down at the number sentence. How can you use the commutative property to know that, see, 1, 2, 3, so this is 3, times 1, 2, 3, 4, 5, 6. So we have 3 times 6, or we have 1, 2, 3, 4, 5, 6, with how many in each row? 1, 2, 3. So how can you use the community property to know that 3 times 6 is equal to 6 times 3? Well, they're flip-flopped. That's the rule. That's the property, is that you take the two numbers and you flip-flop them around. Is 3 times 6 the same as 6 times 3? Yes, it is. So this is the community property of multiplication. We'll get started on the practice side in a minute.